Student, in this video I'm going to discuss about a small topic. It is about top-down design and bottom-up design approach in soft system analysis and design course. That is about, suppose you want to develop a model or a software or a system, you might approach in these two way. One might be top-down approach, one might be bottom-up approach. An overview of the system is formulated without going into detail for any part of it. So in case of top-down approach, initially you can draw or you can formulate the overview of the system without knowing or without going into the detail for any part of it. Each part of the system is then redefined in more details. When time goes on, you going to design or you are going to redefine or refine every part of the system in more details. Each new part may then be refined again, define it in yet more details until the entire specification is detailed enough to validate the model. So each new part may then be refined again. Whenever you add new part, you can refine it again, refine the original design again, define it yet more details until entire specification is detailed enough to validate the model. So you can go on until and unless you meet the desired or entire required specification and also the model get validated enough. Top-down concept in problem solving. If we look at a problem as a whole, it may seem impossible to solve because it is so complex. For example, suppose you want to write a university system program or you want to write a word processor. That type of complex problem sometimes it is tough to look the problem as a whole. It may be seen impossible to solve because it is too complex. But complex problem can be solved using top-down design, also known as stepwise refinement, where we break the problem into parts, then break the parts into subparts. Soon each of the parts will be easy to do. Like here you can see the design approach. Its main task will be done first, then the subtask and subtask 2, subtask 3. Again the subtasks can be divided in more subtasks of the subtask 1 and subtask 2. Like that we go on and on until and unless whenever the each part or in every subtask is easy to do. Like suppose you want to do some quadratic solving equation. Okay, you want to develop a software which solve the quadratic equations. Then you try to get the equation first, that is a one task. You try to get the delta value another equation. You try to find the solution in another function. Again you can go for more division of these functions, try to take the values of x or variables like that, like the any other more information regarding the delta, any other solution part of the solution functions, you can divide more and more. In that way you can go on. So initially while you are doing it, you don't know what you are going to do, but when you divide it you can get the picture, and as a whole at last it becomes easy to solve every part. So after solving every part you will get the actual picture. So advantages of top-down design is that breaking the problem into parts helps us to clarify what needs to be done. At each step of refinement, the new parts become less complicated and therefore easier to figure out. Parts of the solution may turn out to be reusable. So sometimes what happens is that some parts of the solution may turn out to be reusable, means some parts may be used in another part or another subtask or another task. So that is why it is very important, and parts of the solution may turn out to be reusable. Breaking the problem into parts allows more than one person to work on the solution. Obviously, when you divide the main problem in various parts, then lots of people or different people work on the same problem because they are working at different parts of the problem. So as a whole, they are working for the same problem to find the solution. For example, suppose you need to draw this picture of a house. Suppose this is a problem, you need to develop a program to draw this picture of a house. First, you try to draw the outline of the house. You draw the outline of the house. Then you try to draw the chimney. So main function is that there will be a main function. In that main function, there will be draw the outline first function, draw the chimney function, draw the door function, draw the windows functions. That is the initial level. And again, you can go with this, like for a door also, you can use draw the door frame, draw the knob. Like that way, you can divide more and more for every functions. So the door has both a frame and a knob. We could break this into steps. Like that way, for any other function also we can divide it, or we can go for more detailing or refinement, and until and unless we met the specification of that house, and we can validate the model or validate the program, validate the software or validate the systems. And in bottom-up design, individual parts of the system are specified in details. The parts are then linked together to form larger components, which are in turn linked until the complete system is formed. So what is the difference in bottom-up design is that we actually start with the individual parts first, not the original bigger picture, not try to go to the bigger picture. Try to create some individual parts or basic parts as a first, then try to link them up, and when we link them up, try to form a larger components, and in that way we go up, from bottom to up, which are in turn linked until a complete system is formed. Object-oriented language such as C++, Java used in bottom-up approach, where each subject or each object is identified first. So what will be the design? This is the design approach, but I have not detailed these things in this video, because I would like you to go for more research on these things to know how you can detail up these things using an example. Try to understand this using books or using any literatures from the internet, or try to design these things, how we can go for this bottom-up design. So how we can get this bottom-up design approach, as I have given these slides for basic informations, so you can understand, because in C++ or Java we can use this bottom-up approach many times, because we always go for defining the objects first, then we go for the main programming part. So you can understand how we can design the bottom-up approach. You can go for more about these things in books or in literatures in the internet. So that's it in this video. This is a small topic. If you have any confusion or doubts, let me know. I will try to solve it over the Google Meet. Thank you.